one. We're going to find the equation of the tangent and normal to the curve y equals x squared minus 3x minus 1 at x equals 0. Then we're going to draw our curve, tangent, and normal line all together. So what we're going to use is the definition of the derivative, which is the same as the slope. So we're going to use this format. That's actually what the question asked for, but I didn't have time to put it on there, or it wouldn't fit on there. So since we have y instead of f, let's write this as, rewrite the formula as the limit as h approaches 0. So instead of f, I'm going to write y, and then we have this x. Our x is 0, so I'm going to put 0 plus h minus f of, not f, but y of 0. We usually use f, so I'll just do it that way. All divided by h. So now we can just substitute everything in to our equation. Of course, 0 plus h is just going to be h. That's going to make it kind of easy for us. So we're going to take the limit as h approaches 0. Taking this equation, you're just going to substitute in h. So it's going to be h squared minus 3h minus 1. And then you're going to substitute in your 0 here, and that's going to be negative 1. All divided by h. Now, let's simplify this. Basically, what's going to happen, I think we can do this here. This piece right in here, this is going to be negative 1 plus 1. So that's just going to be 0. So we're going to have the limit as h approaches 0 of, and I'm going to factor out an h times h minus 3 divided by h. And then when you cancel out the h's, we can apply the limit. And when you substitute h for 0, you're going to get this equals negative 3. So our slope equals negative 3. All right. You could have also on this, I factored out an h, and I know that bothers some students. What you could have done is just taken h squared divided by h minus 3h divided by h. Just divided each term by h and still got your h minus 3. Now let's go ahead and get our tangent and normal. So the slope for the tangent is going to be negative 3. It passes through the point 0, comma, y of 0. So that's going to be 0, comma, when you substitute in 0 into these x's, you're going to get negative 1, which is actually the y-intercept. So let's write this out. We're going to have y minus a negative 1 equals negative 3 times x minus 0. And this is just going to give you y equals, this is going to end up being plus. So you have negative 3x, and so subtract 1 from both sides, that's going to be minus 1. So that's the equation of the tangent. Now your normal slope is going to be the negative reciprocal, so that's just going to be 1/3. So it's going to be the same thing, y plus 1 equals 1/3 x. We don't need the 0. So y equals 1/3 x minus 1. And that's the equation of the normal to the curve. All right, I went ahead and graphed this. This one required the quadratic formula. It's probably better if you just use the calculator on this one to get it a better framework. So mine's more of a sketch. I did get the y-intercept here, and we know it the lines pass through this point. So that's going to be good. But other than that, the rest is just the estimate. Now, what was our tangent line was y equals negative 3x minus 1. So it goes through negative 1. Then I'm going to go up 3, 1, 2, 3 over 1. So it kind of goes through this point here. It touches like that. That's your tangent. All right. And then your normal was y equals 1/3 x minus 1. So that means we're going up 1 over 3. So there is your normal. And it should be perpendicular to your tangent. Again, it's probably better if you use the calculator on this one. Thank you. Have a nice day. Bye-bye.